Hello everyone, this is Rahul Shrestha here to present the fourth part of the chapter Rest and Motion for class 8. So in our last class, we learnt what is acceleration and derived 4 different equations of motions using different techniques. Now having presented these equations, I might have said that we'll be using these equations to solve numerical problems. And it is quite easy as well to do so if you remember these equations beforehand and also that you know how and when to use them. But a lot of times I have seen students struggle to understand which one of these 4 equations to use when provided with a problem. So today we'll learn the usage of these equations and learn how to properly select an equation out of the given 4 equations depending upon the question which is provided. So if you see these equations properly, you'll find that each one of these equations lack one of the 5 variables from our SWAT abbreviations. If we look at the first equation which we derived from the definition of acceleration, v equals to u plus at, this equation lacks s or the displacement. So if a question doesn't give us the value of this s, or if it doesn't ask for this value, we'll be using this equation there to solve the problem. In the same manner, the second equation, s equals to u plus v upon 2 multiplied by t, lacks a or the acceleration. So we'll use this equation to solve a problem which doesn't express acceleration. The third equation, s is equal to ut plus half at square, doesn't possess v or final velocity and will be used in questions which lack final velocity. And in the same manner, the last equation, v square equals to u square plus 2as, is to be used when the question doesn't propose anything about t or the time period. Let me use one or two examples to show you how to use these equations. So suppose if the question is a car gains an acceleration of 4 meters per second square after starting from rest, calculates its velocity after 1 minute. So here the things which are given are the car gains acceleration of 4 meters per second square. So acceleration A is 4 meters per second square after starting from rest, which means that initial velocity u is 0 meters per second. And it is telling to calculate the velocity after time t, which is 1 minute. So if we convert this to the SI unit, it will be 60 seconds. And we need to find the velocity or final velocity v. Now, out of the 5 variables of SWAT, we don't have s or the displacement here. So we'll be using the first equation, which is v is equal to u plus at here. Now placing these values in the respective places, we have v equals to 0 meter per second plus 4 meter per second square multiplied by 60 seconds. Now we can cancel this too, and now if we multiply both of these, we will get the final velocity to be 240 meters per second. Now let's look at one more question. Suppose a rock is dropped off a cliff and it takes 2 seconds to hit the sea. How high is the cliff? So what are the quantities given by this question? A rock is dropped off the cliff. It means the rock before being dropped was at rest. So here initial velocity or u is 0 meter per second. It takes 2 seconds to hit the sea. So time t is 2 seconds. Because the rock is falling under the influence of gravity, here acceleration or a is the acceleration due to gravity and hence will be 9.8 meter per second square. And then the question, how high is the cliff, asked for the distance, which is s. So if you see, out of the 5 variables, we have 4 of them, which is u, t, a and s. And what is missing is the final velocity, which is v. So we'll be using the formula which lacks v, which is s equals to ut plus half at square. And by applying these values in the formula, we'll have s equals to u is 0, t is 2 seconds, plus 1 upon 2, A is 9.8 and T again is 2 square. Now anything multiplied by 0 is 0. So this will be 0 plus 1 upon 2 into 9.8 multiplied by 2 square, which is 4. And this will give us the distance to be 19.6 meter. Now if you look at both of these solutions together, you can see that the very first thing we need to do is write all the quantities which are given in our questions. Then convert the quantities to their SI units if they are not already so. Then check which variable out of S, U, V, A and T is missing from the question and then apply the proper equation to find the quantity being asked. So this is how you can easily solve most of your problems regarding motion. Do try to solve the questions given in your books, and I'm quite sure most of you would be able to solve all the problems. Now let's move forward into the last part of our chapter, which is relative velocity. See, generally whenever an object is in motion, we take the earth or the earth's surface as the frame of reference and specify the velocity of that body with respect to the earth's surface, which we assume to be at rest. So if we say that a car is moving with the velocity of 40 km per hour, it means that the car is moving 40 km per hour relative to the earth's surface. But sometimes we also need to specify velocity relative to something or someone which is in motion itself. And for those situations, we use relative velocities. The velocity of a body with respect to another body when both the bodies are in motion is known as the relative velocity. Or simply, relative velocity of a moving body is its velocity with respect to a body which is itself in motion. So, the relative velocity of a body with respect to a body moving in the other direction is given by velocity of A with respect to B is velocity of A plus velocity of B, and velocity of B with respect to A is velocity of B plus velocity of A. In the same manner, the relative velocity of a body with respect to a body moving in the same direction is given by velocity of A with respect to B is velocity of A minus velocity of B, and velocity of B with respect to A is velocity of B minus velocity of A. Suppose there are two cars A and B moving in the opposite directions with the speed of 10 meters per second and 20 meters per second respectively. Now if we find the relative velocity of car A with respect to car B, it will be velocity of A, which is 10 meters per second, plus velocity of B 20 meters per second, which is 30 meters per second. Now try and understand what it means. See, if both these cars start to move with the speed of 10 meters per second and 20 meters per second, after exactly 1 second, car A would have moved 10 meters from the initial position and car B would have moved 20 meters from its initial position. But what if we consider both of these cars as the reference point for each other? How much is the car A away from car B? The answer can be found by adding both of these distances, which will be 30 meters. So both these cars are going apart from each other 30 meters per second, and this is their relative velocity. So the relative velocity of car A with respect to car B is 30 meters per second, which means car A is going 30 meters away from car B every single second. And in the same manner, the relative velocity of car B with respect to car A is also 30 meters per second, as car B is also going 30 meters away from car A every second. Now suppose these two cars are moving in the same direction with the velocity 10 meters per second and 20 meters per second. Now after 1 second, car A would have moved 10 meters and car B would have moved 20 meters from the initial position. But how much are the car away from each other now? For finding out this, we again need to find the relative velocity. So the velocity of car A with respect to car B is velocity of A minus velocity of B, which will be 10 minus 20 meters per second, which is minus 10 meters per second. This minus 10 meter per second tells us that car A is lagging behind car B by 10 meters every single second. And in the same manner, car B is going 10 meters away from car A with every passing second. So here, the relative velocity of car B with respect to car A will be 10 meters per second. There are some numericals related to relative motions given in your exercise as well. Try to solve them using the same techniques and formulas. I'm done with today's class as well as the chapter. We'll meet again the next time. Till then, take care and be safe. Thank you.